All right, ladies and gentlemen, so today we're going to be working on solving radical equations. So we've been working on expressions and how we go about, going through and simplifying those. Now we're going to look at, well, what do I have to do in order to solve them? Well, a radical expression, or equation, sorry, is an equation with a variable as a radicand. Which again, you guys know is, I think, a very silly word. And extraneous solutions. In order to go about solving square root equations, you have to then square, you're going to end up squaring both sides of the problem. Okay, well, sometimes when you do that, you end up getting a solution that isn't going to work in your original equation. So extraneous solutions are answers that don't work in the original. Which means sometimes you have to reject them, and that's one of my favorite parts to do. So in order to do these, you have to have the radical, you have to cancel any coefficients to the other side. All right, so first thing we need to do is to cancel any coefficients. So we need to get rid of any of, and not coefficients, we need to get rid of any constants to the other side. So when I look at number one, I don't have any, here's my y. I need to get the y by itself. That's still our goal in any equation that we're solving. It's just now we're going to add in a few more steps. I don't have any constants over here that I need to move. So what I'm going to do is I'm going to square both sides of the equation. Well, you have to remember that squaring and square rooting are inverses of each other, which means they cancel each other out. So over on this side, square root of y and the squared cancel out. I'm left with just y. Over here, because these are being multiplied, I have to share the squaring. So this is really 2 squared and the square root of 3 squared. So 2 squared we know is 4. Square root and squaring cancel each other out, which is 3, and then we're going to multiply. Now, I showed more steps. Some of you could just do that in your head, and that's fine. But you do need to show that you're squaring both sides, and then you would need to show that 12 equals y. You do need to go in and check these. Oh, I can't even spell today. I was going to write yes. Sorry. So we do need to check these, and to check them, we put our answer back into our original equation. So this is 2 radical 3 equals the square root of 12. And then I can either put this in my calculator, or I can go through and reduce this, simplify it, because I can take the square root of 12 and break it up into the square root of 4 and the square root of 3. Square root of 4 is 2. So we have 2 radical 3 equals 2 radical 3. It checks. All right, for number 2, now I need to get, here's my a. I have to get rid of the 2 first, right? So I'm going to add 2 to both sides. So I have 2 radical 3a equals 9. Now, because the 2 is not underneath the radical sign, I need to divide by 2, and I'm going to keep it as a fraction. So this is really the square root of 3a equals 9 over 2. Now I can get rid of my square root sign. So I'm going to square both sides, and I did not leave myself enough room. These cancel each other out, so that's 3a. I have to, again, share. So 9 squared is 81, 2 squared is 4. I still have to get rid of the 3, right? I still have to get a by itself. So I'm going to multiply by 1/3. I'm going to finish this up over here. So this should be 27/4, which you can leave as 27/4. You can then go through and do, you could turn it into a decimal if you wanted. Just to save some time, I'm not going to show the check for this one. And again, it's partly because I didn't leave enough room. So you need to get that radical part by itself. and then you need to square both sides. So over here, the radical part is by itself, so I can go through and just square both sides. Square root and squaring cancel each other out. So I'm left with x minus 4. 6 squared is 36. Now I just have to finish getting x by itself, so we're going to add 4 to both sides, which gives me 40. Okay? All right, so let's go over here and look at number 4. So again, I have the radical part by itself, so now I need to square both sides. When I do that, I'm going to get square root and squaring cancel each other out. 6x squared plus 5x. 2 squared is 4. Now, this is a quadratic, which means I now need to get one side equal to 0. So this is where the work from last chapter comes in. Oops, sorry, forgot the minus 4. So from here, I can do a couple of different things. I could try, my first thing is to always try factoring. So I don't have this as a 1, so I have to multiply 6 and 4, 24. I need factors of 24 that subtract to give me 5. All right, well, I'm going to do my chart. I need factors of 24. So my factors are 1 and 24, which is a difference of 23. 2 and 12, which is a difference of 10. 3 and 8, difference of 5. So those are the factors I need. So when I have that my leading coefficient is not a 1, this is where we do our substituting, and we're going to factor by grouping. So I'm going to put 6x squared minus 3x plus 8x minus 4 equals 0. Okay, so group these. So some of these problems get long. It's pulling a lot of information together. I can pull out a 3x, which leaves me with x minus 1. I can pull out a 4, which leaves me with, oops, sorry, that should have been 2x minus 1, which leaves me with 2x minus 1. These match, so my factors, I'm going to end up skipping number 5 because I don't have room. 3x plus 4 equals 0, and 2x minus 1 equals 0. So finish solving these. Oh my gosh. So x is negative 4/3, and x is 1/2. Now, this is where we would need to go through and check these, but honestly, because we got fractions and it's going to take a long time, I'm going to check a different one a little bit later. But that's what you got for your x. So there's a lot of work. We're starting to put all of our information together. Okay, moving on to number 6, because again, I ran out of room for number 5. So I need to get my radical expression by itself first. So I have to subtract 3. Right, which gives me 8. Now I need to, because the 2 is outside the radical, I have to multiply by 1/2 to get the radical part by itself. So I have the square root of 3x over 5, and that should all be in the square root symbol. Half of 8 is 4. Now I can square both sides. Right, so you have to get that radical piece by itself. So when I square both sides, that's going to give me 3x over 5 equals 16. I'm going to multiply by 5/3 because we're multiplying by the reciprocal. So x is, sorry, I'm grabbing my calculator. 16 times 5 is 80, so 80/3. So notice the reason that I ended up with only one x value in number 6 compared to 2 x values in number 4 is because in number 4 I have an x squared. X squared means you get 2 x values. In number 6 I only have x. I have an exponent of 1 x value. All right, I want to do number 7. so that we can hopefully try to get a check in for this one as well. So my radical part is by itself, so I have to square both sides. All right, so over on the left, that's going to give me 6x squared minus 4x. On the right, because there's an addition in between, I cannot just distribute my variable. This means x plus 2 times x plus 2. Okay, that's what that's telling me to do, is to take that and square it. So when I do that, right, that's going to be doing my distributive property twice. I'm just going to write down my final answer here, x squared plus 4x plus 4. All right, now we have to, because it has an x squared, we have to get one side equal to 0. So I'm going to subtract x squared, which gives me 5x minus 4x. I could have done that all in one step, so I'm going to actually do that now to get one side equal to 0. So 5x squared minus 8x minus 4 equal to 0. So when there's an x squared, I have to either factor, complete the square, or use the quadratic formula. I prefer factoring. I'm going to look to see, is there a greatest common factor I can pull out? There is not. Then I'm going to look to see, is this a leading coefficient of 1? It is not. So I have to find factors of 20. And again, we're not going to end up doing number 8. So I need factors of 20, and I need them to subtract to give me 8. So difference. So we have 1 and 20, which is 19, 2 and 10, which is 8, so there's my factors. So I'm going to take out negative 8x, and I'm going to put 2 and 10 in. The 10 has to be negative because the 8 is negative. So we're going to have 5x squared minus 10x plus 2x minus 4 equals 0. Then we group. So I can pull a 5x out. Leaves me with x minus 2. I can pull a 2 out. And now I can put 5x and 2 together. So my factors are 5x plus 2 and x minus 2 equals 0. Set those each equal to 0. So x is negative 2/5 and x is 2. And even though this one, I'm going to actually go through and check this one so that you can see. And again, we're going to end up not doing number 9. So here's my check. This is all still for number 7. So my original equation is 6x squared minus 4x equals x plus 2. My first value that I need to fill in is negative 2/5. So square root negative 2/5 squared minus 4 times negative 2/5. Now, thankfully I have a calculator, and I can just put that into my calculator. So remembering though that any time you have a negative base, you have to put it in parentheses. Minus 4 times negative 2/5. So on this side I got 1 3/5. Over on the other side, negative 2/5. And I got 1 3/5. So those work, so my negative 2/5 is okay. Now I have to check the 2. So we have 6x squared minus 4x equals, oops, made that too long, equals x plus 2. So the square root of 6 times 2 squared minus 4 times 2. Okay, I think I can do this one a little bit in my head. This is 2 squared is 4 times 6 is 24 minus 8. 24 minus 8 is oh my gosh. I hope everybody caught what I did.